Let's set this sucker up. Pilot's flying over a straight highway. He determines the angles of depression for 2 mileposts that are 6.6 kilometers per apart, and those are 37 degrees and 44 degrees as shown in the figure. Find the distance of the plane from point A. All right, so we are given this distance here as 6.6 kilometers. And we want to find the distance to the point and the elevation. Okay, so we want to know this length and the elevation. So let's see. Let's fill in some stuff and see what we got. We know the angle in between for the central triangle. So we can label that angle right there. That's 180 minus 37 minus 44. Let's call that one alpha. What's that going to be? 99. Thank you. Again, I should be careful about degrees. Just remind myself. Degrees. So we have a angle, opposite angle, and we have a side. So law of sines is coming to mind, I guess. The picture, however, reminds me of a law of cosines. Can I get any other angles? Why, yes, I can. Well, all right, this looks like a law of sines problem to me. Here's why. Because I'm assuming the plane is flying parallel to the ground. They don't quite say that, do they?
No, it just says the mileposts are 6.6.
Yeah, so I'm assuming that this flight path and the ground are parallel. And if that's the case, then this angle right here is an opposite interior angle to that one. And they have the same measure. So this right here has to be 44 degrees. Same thing with the 37. 37 is an opposite interior angle to that one right there. So this angle right here has to be 37. And that actually makes sense because 37 plus 44 plus 99 should add up to 180 based on our previous calculation. What? We have an error in our calculation.
37 plus 44 plus 90?
9.
99. 99. Yeah, Betty.
Okay, good. We're on the right path then.
Oh, yeah, duh.
Okay, so now that I have all those angles, I can use the law of sines. So let's see, I call this alpha. So that means I would call this side A over here. And then I could call this angle right here beta and this side little b over there. And I want to know what little b is. So then b over the sine of 44 degrees has to equal a 6.6 over the sine of alpha, which is 99 degrees. And so that will give me that distance from point A to the plane. So that's a calculator problem at that point. What about the altitude of the plane, that vertical distance to the ground? What could we use to figure that out?
Well, you could use which one's 37. What you label 37 degrees. Angle. Right, and then, it be, no, because you just did that one, 44 or 99. But I was looking at it more from the angle up top, but I see where I'm looking at it wrong, because that 37 degrees is from the red angle up to the
To
dotted
the
line.
flight of the plane, yeah.
Yeah.
Yeah. And now we can draw this different, right? So I could, draw that altitude out here. And then there's another right triangle sitting out there to play with. But I
We
think,
should
I don't think I want to go there though.
37 minus, or 180 minus 37 minus 90, is that inner?
Oh, to get, say, this angle up here?
Yeah,
I don't think I even need that one. So at this point, I just learned what B is over there. And I want to know the height. What trig function allows us to connect this height here, this angle here, and that length there?
Is that cosine over sine?
Nope. Try again. What trig function is related to this angle, this side, and that side in this right triangle?
B over A.
So this side is opposite that angle, and this would be the hypotenuse. So what's opposite of hypotenuse? Nope. Sine, yeah. Remember, sine of an angle, let's call that angle gamma, is equal to the opposite side divided by the hypotenuse. So in this situation, the altitude I want is opposite. Altitude. The hypotenuse is what I just calculated B for over here, or I'm about to. And the angle is 37. So the sine of 37 degrees is equal to the altitude divided by B. So the altitude has to be B times that sine. So once we find B, then we can find the altitude. Is there another way to find it? Probably. These trig functions have lots of tricks up their sleeves. All right, I'm going to stop there and let you finish it.